So Dr. DuBois is the state climatologist for New Mexico and the associate college professor. As state climatologist, Dr. DuBois focuses on climate literacy through providing climate information and education to the public, speaking engagements, interviews, school demonstrations, social networking, and tours. He is also the New Mexico Community Collaborative Rain, Hail, and Snow, also known as COCRAS, state coordinator. Dr. DuBois chairs the New Mexico Drought Monitoring Work Group for the New Mexico Governor's Drought Task Force. As the state climatologist, he directs the New Mexico Climate Center and oversees the Zia Mesonet, a network of automated surface weather stations through the state. So with that said, welcome Dr. Dave DuBois.
All right, thank you for that introduction, Jesse. Appreciate that. And I'm just going to go ahead and get started. I'm not going to turn my video on until the end, just so that we have enough bandwidth for everybody. So today we're going to be talking about drought, and it's on a lot of people's discussions at the table or at the grocery store. You know, how are you doing? And have you seen any rain? Have you seen any clouds? It's actually some of the conversations I've had. I was just up in Farmington earlier this week, and that was actually a question. So we're going to talk about where we are in drought and where we are now, and then what we're thinking in terms of the future. You know, in the next all the way from tomorrow all the way out to the next several months, the seasonal outlook. So let me get started. I'm going to show a bunch of maps in here and talk about where we've been. So I like to show the U.S. Drought Monitor. That's kind of our all equals in terms of a playing field and comparing drought over the whole western U.S. and actually the whole U.S. But I'm just focusing in on the Southwest here. And so if you're not familiar with it, it's a way to capture and quantify drought in units of drought categories from D1 to 4, 4 being the worst, exceptional drought, and then 1 being moderate. And then we called this D0 as sort of pre-drought or abnormally dry. As you can see, there's big areas of Southwest, including the Four Corners that are in D3. That's that red color, extreme drought. And across the whole Southwest, areas that have both D3 and D4, it's more than half of the entire Southwest is in the 2 worst categories of drought. And right now, about 16% of the Southwest is in that darkest red color. That's the D4. And we got big swaths of it in New Mexico, as well as in central Utah, southern Nevada, and then the southern extent of this Sierra mountain range. And so in the Four Corners, we've got a mix. We've got some areas that are D1 and like the Chusca Mountains. And if you go up a little further into the Four Corners, we extend into the D3. So that's where we are. And it's pretty much been like that for a while. We haven't really seen much change. There's been some snow in the winter, but not a lot, except in the high elevations. Say like the Chusca Mountains have gotten some good snow, but as you go in further down in elevation, that's kind of where the drought is really hit. And you know, and speaking of, and I'll talk a little bit about the snowpack, but just kind of seeing this is kind of a pattern that we've seen, and it's caused, at least this last couple years, have been kind of magnified by this La Nina episode, and we'll talk a little more about that a little later. But that's kind of what's been really pushed the drought over this last year, and including even after last summer, that we've gotten some decent rains from the last monsoon. In places, there's a few places that missed out, but overall the monsoon was not that bad, and overall, and we'll see what happens for this summer. And so in terms of change, here's our areas where the most worsening of the drought has occurred over in the Southern Great Plains into eastern New Mexico. In all of New Mexico, and these are the change in the drought monitor classification since the water year. So the end of September through a couple of days ago, how many different categories have we gotten worse? And you can see the legend here. There's a few areas that has gotten all the way to 5 class worsening in drought over here. And then in the Four Corners, there's a few areas where it's actually improved just a bit or no change. So there's a big gradient from, even in southern Colorado, in the mountain range, just on the border from Taos County into, I guess that's Costilla County, Colorado. There's been some deepening of drought in that area. So that's where we are in the past water year. And let's go a little deeper in terms of the climate. So this is the temperature over the whole water year. So that's October, November, December, all the way to the end of May. If you look at that time period, how does that time period compare to other water years going all the way back to 1980? So if you kind of rank them, this is what this year ranks compared to all other water years in terms of mean average, so average temperature. So you can see this kind of yellow to this mustard color, and so the yellow is the above normal, it's the top 33, and then the orange mustardy color, that's in the top 10%. So in terms of the warming, it's pretty warm. So there's very little areas that have cool colors like this blue. A few little spots in southern Utah or in the Great Basin here, but pretty much everywhere it's either the top 33 or the top 10% in terms of average temperature. So it's been a warm season in terms of all the way from October on to a warm winter. There's been some cool months, but if you look at it over the entire water year so far, it's warm. And then what about precip? So it's a very similar story in terms of the ranking. However, it's on the other end. We're in the low end of the percentile. So you can see this mustard color is the bottom 10 instead of the temperature. We're on the top 10. The precips are in the bottom 10 percentiles, and yellows is in the bottom 33%. So much below average, and below average for almost all of New Mexico, southwestern Colorado, southern Utah, and most of Arizona, as well as in the southern part of Nevada and the eastern California. And so there's just a few areas where we're right around near normal in northeast Arizona. So that's kind of that's the picture we're painting here. And that's kind of what, if you look at the whole water year, it's warm and it's dry. And it's kind of not as really a big surprise to you all who live here. That's kind of what we've been seeing. And I just wanted to pick one weather station that kind of demonstrates this picture here. So this is a weather station. This is actually a rain gauge in Farmington at the Agricultural Science Center. That's just on the mesa south of town in the Nappy area. So this is the accumulated precipitation since October 1st of last year. So you can see each vertical line is a month, and the green line is the actual precipitation accumulated, and then this brownish smooth line, that's the average. So that we call that the climate normal, or just call average. So as you can see, if the green line is below the average, then we're below average and we're missing out. So we started off not too bad, but we had a pretty dry start to the winter. And then we had a bit of precip in December and January, but then it's really dried off since then. We've had a little bit of rain in February, but it's like we've had this really dry spell here since the end of March, early April until now. And so if you look at the accumulated precip at Farmington, they've received just under 3 inches, and the long-term average is just under 5 inches. So, and if you rank those into all other water years at that location, it's the 5th driest water year on record at this location, and that the weather station that at that area goes back to 1978. So it doesn't go all the way back to 1900, but regardless, it's a really dry year, even in this location. And if you look at other points along in the Four Corners and most all of New Mexico and Arizona, it's very similar. There's a few areas even worse. Some of the areas that are in that D4, I can show you that, like Roswell and Chavez County, New Mexico. Basically, they've had very little rain since October. They had a few bumps, and then it's pretty flat all the way over. They had just around an inch of rain the entire water year, just a little more. But they've been starting to get a little bit of precipitation now, and we'll talk a bit about that later on here. So I'm going to talk a little bit more about surface water storage. So we've basically melted out most all of the snowpack. It's coming down as runoff, and our hope always is to see the runoff and come in and start filling up reservoirs. However, that's not the case. I mean, we were getting runoff, and in some places we've peaked already. And so this is the Colorado Basin. So on the left side is the lower Colorado, and our big reservoir there, as we all know, is Lake Mead, and that's at 28% of capacity right now. And as we know, if you look at the news, you can see all that what they're looking at the conservation and and drought, and having programs that we need to decrease the usage, because there's not a lot of water left. There's more demand than there is water. So, and a lot of people drink from that straw. And so if you go up in the upper Colorado, which is the map over on the right here, you can see a little up on the Colorado. Lake Powell is 28% of capacity. Navajo is 57% in capacity. Blue Mesa 46%. And some other ones like Flaming Gore is a little more up there, 75%. So as you get further south, the drought actually intensifies. They've had some snow this wintertime, both in all the basins in Colorado and in northern New Mexico. In a few areas about average, but it's melted out early. It's peaked early. We were on track for about average, and we're going up leading up to the peak of the snow water equivalent, but we saw it really dip fast because of the warm temperatures, and we saw that runoff come up very, very soon. So that's the Colorado. This will go a little further to the east into the Rio Grande and Pecos, as well as the Chama. So on the left side here, that's the Rio Grande. So this is kind of the same kind of picture on the Colorado. This is kind of result of many years of drought. So remember, we're 20 more than 20 years into our current drought, and a lot of people call it the mega drought because it's a couple decades. And you kind of see that we're right now at about 10% of our largest reservoir on the Rio Grande, and about 11% in Caballo, and we basically just started irrigation. And it's going to be a short irrigation for that basin. And so only 195,000 acre feet. Remember, that's over 2 million is the capacity. And so further over on the Pecos, similar story in terms of the how much water is in there now. They're in the 20%, 28 in Brantley down to 21 in Avalon. And if you go up into the upper parts of the Rio Grande into Chama Basin, 48% in Abiquiu, and Herons at 20%. This one is at low because they're actually working on the dam. The water is passing through, so it's kind of ignore that for now. But basically, what that does is we don't have that capacity to store any water because we don't have El Vado, and that has a capacity over 100,000 acre feet. So it's I don't want to paint really bad pictures, but it's sort of that's kind of where we are. And it's more of how do we adapt to this and figuring out ways to use less water and wait for the next if we're looking for an El Nino or something, but that's not going to come right soon. But it's more of, okay, how do we manage with this kind of water is kind of the takeaways when we see this, because we don't have a lot water to give out right now. And as a sign of that, you can see the stream flows on the left side is the one of the gauging stations on the Rio Grande, the Ottawee bridge gauge. The blue is the actual, and the long-term average, which is 51 years of data, is the little triangles here. So you can see we peaked runoff in late April, and as we were going down into pretty low flow territories, only 5, 6, 7, 800 CFS, and what we should be around over 2,000 CFS, cubic feet per second. And if you go on the right, that's the San Juan gauge at Shiprock. So the long-term average, which is 87 years of data, that's these triangles here. We should be at this time near over 4,000, and we're down. We're less than 1,000 right now in terms of the actual stream flow. I drove by there just recently, and it looks, there's water there, but it's if you got to look at the numbers to see how much difference it is compared to the long-term average. So that's kind of the sign we're seeing, with that early runoff, less snowpack or later in the season. That this is the result of that. So it kind of makes sense when you look at the whole picture of the water cycle in these basins. So other impacts of drought that we look at are not only the precipitation, snow, but also where is it going into the soils? Because that's really important. So this is one product we're looking at. This is the GRACE. It's a satellite-based soil moisture. And this is just a few days ago. And it basically ranks it in terms of percentile compared to what this right now looks like compared to the past. And the past is going all the way back to 1948. And you can see that the numbers, the colors are, that red and the orange, that's the orange is down to 10 percentile, and then the red is 5. And then the dark red is, it's bottom of the barrel, 2% and below. So we're seeing that impact to the ecosystem and drying soils. A few areas like the Chusca Mountains, it's kind of stand out, but everywhere else, it's been pretty dry. Another mapping product that I use a lot. It's an index that basically looks that uses winds, solar temperature, humidities, and evaporation, and it combines all those. Because that's kind of what's going on. If you go outside, you're losing water from all those phenomena, and if you put it all into an index and you rank them, this is kind of what it is. It basically measures the thirst of the atmosphere. And thirsty meaning like if you go outside, you basically want to drink some water really quickly because of all that evaporation and the high temperatures and winds. It's been a windy season this past year, and as you can see, the colors here are that they ranking in terms of the percentiles. So it's the big areas where it's kind of really dry and a lot of evaporation is going. So, and even if something comes from the sky, meaning precipitation, it's going to come down, but where is it going to go? Is it going to go in the soils? And it's when you get these really dry categories, as soon as that water comes down, it's going to go right back up again in terms of evaporation or transpiration if it's in a plant. So that's that gauge that we use to measure how bad the drought is in terms of comparing, the evaporative properties of the atmosphere. So as you can see, most all of the four corners is in this the third category, the ED3, and big parts of the Southwest are all in this the worst case, the 4. So this is one of the we like to look at this and how is it going and where are we right now, and we look at it in different time scales. This is the 2 months. If you compare the last 2 months with a whole bunch of other 2 months, this is where we are. So we're seeing it all the different time scales. I just showed you one. Even at the 1 week, this past week has been drier than other past weeks all the way back to 1948. So another thing we look at is so that it's another combined index. It basically tells the same story. This one is called the Quick Dry, and it's the Quick Drought Response Index. It looks at the conditions over the last 4 weeks and compares them to other 4 weeks going all the way back in time. And so it ranks them and it puts them into this color. So the brown is the drier, than average. And then if it's white, it's right about average. And if it's in the blue categories, it's wetter than average. So you can see almost all of the Southwest is in that drier, except for the high elevations here and the Four Corners. But it's that this combines precipitation, evapotranspiration, soil moisture, and also vegetation health. So it uses satellite-based observations to make this index. So it's that there's not a lot of good news in terms of the amount of drought impacts, except for a few areas. So it's that we got to be cautious and looking at how much rainfall, and then how we can't expect a whole lot. Even if it does give it a lot of rain, we got to wait it out in terms of letting the ecosystem respond and heal over time. So we need some good rains for an extended amount of time to really recuperate, bring up those numbers. Remember that weather station in Farmington, which is right about there, we were behind several inches of rain, and so it's going to take a while to recoup on that. And so some of the other impacts that we're seeing as wildfires, we all know we've had fires in both states, in Arizona and in New Mexico, and even in Utah. And so these are the total acres burned all the way back to 1990. This is just for New Mexico. We all remember 2011 really bad wildfires back then, but this 2022 is coming as the second most acres burned and through this whole time period since 1990. So it's kind of the sign of our thirst of the atmosphere, as well as the impacts of drying. And then we've had a lot of the forests being stressed, and insects have moved in, and it's even it furthers and accelerates the fuel loading and stress that the forests are having, all the way from the pines, not only just the big pines like ponderosas, but also the pinyon. I'm driven on Highway 550 coming back from Farmington. I see that the pinion's really stressed out, and there's a lot of death in the pinyons. That's sort of that problem of fuel generation and insects as well. And so I just wanted to show one loop of the satellite. This is from just a few days ago, and just showing you the fires, as well as the aridity, the dryness of soils all across the area. We're seeing dust being, wind erosion being a big part of what we're seeing across the landscape, as well as the fires. And we've seen lots of wind erosion events in all along in the east side of the Navajo tribal area, over here south of Shiprock and north of Gallup. We're seeing lots of wind erosion there, and we've seen it all through the wintertime. And it's actually caused some dust on snow episodes and that it has accelerated the melt out in the San Juan Mountains and actually some parts of the Sangre de Cristo is because of the dust. It provides a feedback mechanism. It accelerates the water cycle to speed up the melt. So that's another issue. And this is these two. I got two examples of this. This is one that was in beginning of May. That the pink colors is dust, and so this was in the afternoon on May 2nd. The dust was blowing into off of San Juan County and going into southwest Colorado. And then another one recently, just a couple days ago on June 13th. This one also coming off of northeast Arizona, as well as in San Juan County. So a lot of the snowpack has already melted off, but it's just we're losing valuable topsoil when we get these events in the dust events. And it's not only that, but it's also impacting our health, because some of a lot of the particles are pretty large, but then there's a good number of those are very small that are impacting our respiratory health. So it affects all of our well-being, not just seeing the nutrients fly, but it's impacting our health. And so I want to talk a little bit about what's going on in the future. We, as climatologists, we don't have crystal balls. but we have models, and we've got past data to kind of help us guide ourselves. And so this is these are forecast probabilities. So basically, this is for looking at the seasonal for next winter. And so we're right now is we got three different choices for the wintertime seasonal outlook. We have we're using the El Nino Southern Index, which is we can either have an El Nino or neutral or a La Nina, and that's what the three colors are. So the blue is the probabilities for the La Nina, which we're in right now, and that's typically is a drier and warmer state of the atmosphere and our ecosystem in the winter times. And the neutral can be either one. We've seen both wetter and drier, but then the El Ninos is what we really like, is to get a cooler and wetter, typically. Not every one, but you can see the probabilities go from 0 to 100. So this is currently right now. So we're in the La Nina. It's slam dunk. But as we go further in the season, later in the summer, the probabilities go down. However, it's still there. It's the most highest probability out there. This blue, which is the La Nina, and then this gray line pops up in terms of probabilities, but it's still below the. It's not out competing the La Nina, the neutrals. And then our poor El Ninos are down here. It's extremely unlikely that we'll get the El Nino. And these are all triggered by the coolness or warmness of the Central Pacific. So when we see the blue, that's when the Central Pacific is cooler than average. And then the red is when we get a warmer than average Pacific. Right now, it's a cool waters out there in the Pacific. So what we're seeing is that the models which just came out, that this La Nina is going to stick around again. And we've had two, and we really haven't gotten out of it. But these La Ninas are usually counted during only winters. We don't really see a strong connection between La Ninas or El Ninos during summers. So it's basically looking ahead out toward the next winter time. Likely going to be seeing, here's our winter over here. It could be either a weak La Nina or a neutral, but it seems likely that the La Nina will stick around. So remember, again, like I said, those are typically warmer and drier. So we hope we hope we get a exception out of the case where we get a wet one, but I wouldn't put a lot of money on it. It's kind of favoring another drier winter. But we got to wait and see. We get a little more better predictability while we get into after the summer to see how these probabilities line up. So how does that line up? So let me get kind of look into forecasting. I want to go all the way from short term, and then I'll go all the way to long term. So this is the good news I wanted to share. This is the 7-day, the 1 week outlook for precipitation starting this afternoon, going all the way out to Thursday of next week. And so as you can see there, you can see the North American monsoon is bringing in moisture, and we finally actually just transitioned this afternoon to a southerly flow. So the winds, and it's basically, I'll show you why, but basically that's drawing in moisture in from the Gulf and bringing it in here. And so that's our good news right now. So I mean, I've shared just a ton of bad news, and I hope I didn't depress anybody, but this is our good news, is we're going to see right now it's starting off as a healthy and early monsoon all the way up to the Four Corners, which is great. That's the answer to prayer here, is seeing that red. We're not, that all the way to that blue. I mean, that purple color is about an inch of rain. And that's just the next 7 days. And this is the reason why. So this is the forecast over the next, from now until Monday. So basically we're seeing this high parked over in the Southern Great Plains, Texas, Oklahoma. And then we've got a low parked out over the northern California, and kind of slowly moving. It's which is great. We really want to keep this slow moving and keep this high over to our east. And so basically what the number highs, as you can see, they're bringing this clockwise motion, and then this low here is bringing in this counterclockwise motion, and it's just right where it's starting to bring in. So I colored this green. That's relative humidity more than 50%. To 100%. So the very deep green is 100%. So that's basically showing cloud cover at mid levels. This is all at mid levels in the atmosphere. So it's kind of like this gears, kind of drawing moisture in from the south between the high and low, and that's kind of one of the typical monsoonal patterns. Is if we have that kind of situation throughout the entire summer and even to the late very early spring. Fall. We really want to see that. We want to see the moisture come off of the nice warm parts of southern Mexico. We've got some tropical disturbances down here as well. If we can peel off some of that, all that moisture and that really warm Gulf of California moisture, that's kind of the pattern we want to see, and that's what we're seeing over this coming weekend. So, which is good. That's great. And so how does that pan out in terms of probabilities over the next 10 days, 6 to 10 days? Good. Near normal temperatures, very warm over most of the country. And then over on the right here is a precipitation looking really good at the Four Corners and all of half of New Mexico and most of Arizona. So we're going to benefit from this, at least in the short term, the next 10 days. If you go further out, June, July, August, over on the left is it's going to be a warm monsoon. It's going to be a warm summer. Pretty high probability, at least 60% or so above probability of it's going to be above average, leaning very, very, very likely above average. But the important thing is here, even if we got warm monsoon, it looks like it's going to be equal chances or above average for here, and which is a good sign. We'll take this white, this equal chances of either dry or wet, because we can tip either way on there from the moisture coming in from Mexico, and it all depends on that location of the high, and then whatever low is off the coast here. So we really want to draw in that moisture from the south. We really want to have that southerly, southeasterly flow coming this direction. I mean, that's what we're seeing exactly right now is that. And so this just came out, I think today. So the seasonal drought outlook. So basically the chocolate colors are saying drought's going to persist. So that's it's like 60% or even a little more of New Mexico. But as you go further west, this drought remains, but it's going to improve. Remember, that's my takeaway here is, we're still going to have the impacts of drought. That's a done deal, but we're going to see some improvement. And the longer we see these signals of more rain, we're going to start to heal over time. We need that. And a few areas in central Arizona, we're seeing that drought removal is likely all along here. But, here in terms of the Four Corners, it's still going to be around. It's going to take a while for the ecosystem to respond to this drought here. So, and that's my my bad news, but tempered with some good news, with some optimism. And we're looking forward to seeing some rain finally, because there's a lot of areas, especially down here, haven't seen any rain at all since October. Imagine that. That's pretty nasty. So that's all I have for this evening. And I thanks for inviting me to talk. And I'll open up to take any questions.
Okay, thank you, Dave. Go ahead and leave your screen up while we're doing the Q&A session. So if you guys have some questions, go ahead and unmute yourself. If not, you can type it in the chat box. But in the meantime, I do have a question for you, Dave, in regards to the drought. What type of restrictions are out there, especially up here in the Navajo Nation region, Four Corners area?
Yeah, as we all know, the Forest Service is closed. That was kind of expected to see that because of the fire danger. We saw National Weather Service pop up the red flag warnings because it's so dry and it's windy. And so I think I think some of that is going to be in our past. I think with the relative humidities coming up because of the trajectory of the air masses bringing much moisture air, Look at the dew point temperatures and seeing they start to climb up. So that it's going to be harder to burn. It's still going to be easy to burn, but it's going to take a lot more effort, a lot more energy to burn, a lot higher temperatures to burn at a higher relative humidity than a lower one. And so another thing is the fireworks. I don't know. I think I've seen some fireworks restrictions already, and I haven't seen other states. I know New Mexico has some. I know the governor had issued a request that there would be restrictions. I don't know. I would defer to others to answer that question, but I think there's still quite a bit of fire risk out there. I saw a picture from Twitter of the range conditions just west of at almost 10,000 feet in the mountains west of Socorro in central New Mexico, and it was still really dry. And so it was just brown everywhere. So that's a lot of fuel until we really get a lot of moisture to wetten the soils. And so we're losing. So even if we get rain, it's going to be lost. Remember that eddy index that I showed? That's that the impacts of that. Even if we get like a tenth of an inch, a lot of that's going to be lost right away because of our high temperatures. Where we here down in Las Cruces, we were 100-degree plus, and then even the Four Corners was in the 90s. And so I'd still have caution in even as the monsoon starts to kick in. I would still be cautious in terms of doing any fires or anything like that right now.
Right. Okay. Thank you. And I know you're also the state coordinator for the CoCoRaHS program. Do you want to give a quick overview of what the CoCoRaHS is and how everybody can participate in the program?
Absolutely. Let me turn on my camera if I can. Hope it'll work. Yeah, I got my camera set up here, and this is a CoCoRaHS gauge. Let me turn my screen here. So this is what we use for measuring precipitation for the CoCoRaHS. That's the Community Collaborative Rain, Hail, and Snow Network. And so we basically are a bunch of citizens. We're community members that we can become scientists, everybody, and we get this gauge, and basically we measure the rain, and then we look at how much is in here every day. And so this is one way that we could all take part and measure a climate where you are. And I really encourage whoever's listening to consider that. I think we may have some resources to help with gauges, but there's also, we've had some workshops for how to do this. It's not hard. It's basically you look at the rain, how much water settles in here, and then you go on your computer or your smartphone and you just type the number in, and then you're ready to go, and it goes into a national database. And I see that, and it really provides that information to gauge how bad the drought is. And so it not only goes to resource managers, but the general public, as well as it gives you a sense of how bad the drought is or how good the monsoon is going to be. So that's just the perfect time to get started, to start to measure the rainfall in the monsoon, because you have your own number, and you can keep track of your number and how much rain falls. And there's even tools to measure what is your average. We use a model to actually do that. So you can compare, basically at the end of each month. So how much percent of average did I get in my house compared to average? And that's a really good tool, especially if you're looking at range conditions, or how much water do you give cattle. That's a good number to have, is percent of average, to kind of gauge how much is it. Are we looking at other years? We can look at other years and compare it to, say, like 2003, 2002, or the drought of 2011, 2012. Is it how does it compare to those years when we really struggled? So this is one tool that we measure precipitation. That's rain, hail, and snow with this gauge, and it costs about $40. But as like I said, there may be some opportunities to get gauges at a reduced cost or even no cost, depending on which way the wind blows, I guess.
Right. Okay. Thank you. We do have a question. Let's see. Crystal, I know your hand is raised. Go ahead and unmute yourself and ask your question.
Hi, this is Crystal from Navajo Nation Department of Water Resources. I'm a principal hydrologist, and thank you for your presentation. I really appreciate it, especially just seeing some of the imagery of the impacts of dust and what that may mean for precipitation and runoff, etc. But my question relates to La Nina and neutral conditions. I know that you mentioned that doesn't necessarily impact monsoonal, that description for having those, either it's a La Nina or El Nino, neutral, etc. But when does that start tightening up to give us a better understanding about winter precipitation, whether it'll flip either way? If you could elaborate on that, that would be great.
Yeah, that's an excellent question, because we really we desire to have some kind of predictability for all the seasons. And right now we have pretty good short-term predictability for the monsoon, but not long-term. With the winter precip, we have a little better tool. It's not 100% slam dunk. If we do get La Ninas or El Ninos, we'll definitely get this condition, but there's a propensity for different phases, depending on how wet or how strong we'll get, how wet. So it basically it doesn't, it's not like a switch where all of a sudden it's not dependent on La Nina or the ENSO cycle, but it's a slow transition, and it all depends on the way the wind directions. Basically, when we get a switch from back to maybe a more northwesterly flow, which basically is telling us about the positions of the semi-permanent high and low off the coast of California, and also the sea surface temperatures. And so we look at the large scale patterns. So when I look at these, I tend to look at when I tend to move my window to like the Aleutian Islands, and then looking at the Pacific, the storm tracks, where are they going? And then it's basically, and then you can kind of look at it from the point of view of the jet stream. And so when we see the jet stream kind of dipping down, that's kind of the sense of when we see that transition to a more fall or a winter pattern. And we can see that northwesterly flow becomes more predominant, and then we start to see that transition to a more winter pattern. And those are that we get more influence from the like a La Nina or an El Nino, when we get more of those northwesterly, and even depending on what part of the jet stream we can still get the southwesterlies. But it's that as soon as we get out of that southerly flow, that high moves out, goes off, and then we get more of the high moves up, say over the Four Corners or even further north. So it's that transition point. There's always exceptions to that rule, but it's that we kind of look at. I tend to look at air trajectories in order to see the pattern shift. That's kind of one of my personal tools, and it'd be actually fun to actually create some kind of a tool based off of that to kind of see the influence of what's our upwind trajectory. Where are we drawing air from? And it draws air from a northerly pattern. It's usually drier and cooler. And if it's southwesterly or westerly, sometimes, and it depends on how fast they could be, bring in a little more. If it's sitting over the west more, it's kind of dry but warm. And so that's kind of how I view it, and kind of looking at it. Is it repeat over and over again, or is it just one deviation? If it's a consistent pattern, then I say, okay, now we're starting to switch out of monsoonal. We're going more into the fall pattern, which we get kind of southwesterlies. And then when we switch back out to fall to winter, we see more of the northwesterlies. So I don't know if that makes sense. that kind of pattern shift, and we see then we know, okay, the La Nina or El Nino is going to impact more strongly if we finally get out of that phase of the different wind directions.
Thank you. Last question. You mentioned that we had 2 La Ninas prior to what we're now expecting as another La Nina. And I wondered if you could elaborate if they were weak or strong La Ninas of what we experienced recently in the past few years.
Yeah, so this is, like you said, we've already had 2, and a third one looks like it's in our future, and we don't have very many of those in the past. We've had a few, and since we've been measuring sea surface temperatures and the index, and so they weren't particularly strong. They started off as like kind of weak to moderate, and then if there was some spikes in the coolness, it kind of went way down. So they weren't really, if you compare them to other ones, they weren't particularly strong, but it's the combined impact of multiple ones that really has caused our problems, and so that we never really got out of that La Nina phase. So we never really had the we've had the storm tracks come in, so we had lots of storms, lots of wind, but they were really dry systems, and that's kind of the big difference. Why the drought is so deep right now is that it hasn't really been dipping at all in any moisture sources, and even though that they weren't really strong La Ninas.
Okay, thank you, Dave. We also have another person raising their hand. May Franklin, you can go ahead and unmute yourself and ask your question.
Yes, thank you. Thank you for the presentation. I'm over here located in Cameron, western part. So a couple of years ago, we just had a whole lot of feral horses that died. And since then, there really hasn't been any kind of management that has happened to deter some of that in the future. So my question is, of all the maps that you've shown, and what is it that we need to be aware and tracked more when we're talking about going into a drought? I don't know why that particular year happened. So I'm wondering what do we need to be looking at so that maybe we can get more educated and be able to, I guess, respond to the needs of these animals.
Yeah, that's a great question, and I kind of go back to this this map here, kind of illustrate kind of what I'm thinking. You know, I mean, we can even kind of look at the quick dry as also, because that's kind of the same. It's a little more zoomed in. The fact that we have, extended drought, soils are dry, a lot of evaporation, and it depends on elevation. So, what do the animals eat? And, we need sustenance, right? We need protein, food, water. So, the stress, translates not only into vegetation, but animals with higher than average temperatures. It's an incremental increase, as a, higher up higher you still get cool temperatures, but it's warmer than it would be on average. So I think, I would be, worrisome about, further mortality on animals, such as wild horses, without any intervention. The sort of that, you know, without, water, because I know when I've talked to ranchers in New Mexico, they're still doing a lot of manual feeding and hauling water to their stock. And so that hasn't stopped. They've continued to do that. So that's the managed side of animal, managing animals. So it's much harder on the wildlands. So I would still be very concerned about what goes on, because I think there's still a lot of, from last summer, there's still quite a bit of, in some areas, still quite a bit of feedstock, grasses, but I think there's some areas that are pretty low. I mean, just looking at this map, some areas are not doing bad, but the vegetation health is pretty low in some areas. So I would have to look at it from a more detailed examination, what specific areas and what kind of elevation and what kind of feedstocks are out there. I know there's other products. I think one of the future webinars is going to be called Grass Cast. That's one of the tools to use to look at vegetation health is that one. So I would definitely listen in on that webinar to understand that one aspect. Hope that helps.
It's a start.
Okay, great.
Yeah.
And we have another question from Talani Francisco. You have your hand raised. Go ahead and ask your question.
Okay, so my first thing is I'm Dr. DuBois. I don't want to but they're not wild horses. Wild horses it's a legal term, and so those are only horses that are situated with or associated with a BLM, HMA, or a Forest Service wild horse territory. So like in the case on the Navajo, those are just feral horses. So we want to be really careful using that word wild. And to the lady in Cameron, I just want to say that one of the biggest things you can do to prevent something happening like what happened before in Cameron is to really look at your vegetation, like Dr. DuBois was talking about. Look at where your water sources are, what accessibility do they have, are they drying up, and if they are drying up, then close them off so that these animals don't get stuck in the mud. The other biggest thing is the number of animals that you have on the landscape. And so we know that we have appropriate management level, and the Navajo Nation, we've been working with your Department of Natural Resources and trying to get that determined. But for the entire Western United States, it's only 26,000. And on the Navajo Nation, you guys probably have somewhere in the neighborhood of 70 to 80,000. So we know that that's a huge component, is just the number of animals alone on the landscape. So a reduction of those numbers would greatly help preventing something from happening like what happened 2 years ago. So that's all I wanted to say.
Great. Thank you for your comments and shedding light on that. And thank you everyone for your comments and also your questions. Just a few comments from the chat box from Benita and Benita and Linda, and also, great presentation and answers. We have another question from Helena, and then we'll go ahead and wrap up our session. Go ahead, Helena.
Dave, can you speak a little bit about the Zia Mesonet?
Yeah, absolutely. Yeah. So we have, at the state of New Mexico, we had money allocated from the legislature over the past year, and then again this year, for funds to build out the weather monitoring across New Mexico. Sorry, the rest of the Arizona, Utah, or Colorado, but mainly from New Mexico. So we're it's about 2.8 million set aside to basically increase the number of weather stations. And so, we have a big landscape to work on. So there's a lot of area that doesn't have weather stations. And so these are MesoNet, so a 10-meter tower, temperature, humidity, precipitation, winds, wind speed, wind direction, soil moisture, soil temperature, pressure. So pretty much everything you can think of for weather, and coming out at every 5 minutes. And so what we're trying to do is look for locations that basically in between the existing meteorological network. So the existing is a lot of federal programs like RAS and the National Weather Service, airports, and it's a few others, and USDA programs. And so we're looking for locations and ideas for where do we have the greatest need? What are the highest priorities in terms of where would weather data be most used if we were to put a new weather station out? And so that's where I am right now, is looking for ideas. So if anybody has ideas, you can email them. Let me go to my email. I will take all ideas from anybody. So I'm making it wide open right now, and I'd love to have tribal kind of interaction and collaboration, cooperation. Helena and I have, with the Drought Learning Network, we were talking about that, and I think I've gotten some good response from the Pueblo of Santa Ana, and I think as well as Sandia. And so there's already some discussion about that, and we're working on so how will all this work in terms of data. So I'll leave that open, and we can chat offline, or if you want to send me an email, we can talk on the phone, or show you what we have planned. And so our goal is to, since we have this opportunity, we need to make really good use of it. Maybe the only opportunity we get $1 million to get a lot of weather stations. And these are high quality professional weather stations that last. And we also have money for maintenance. So these are going to last and be out there for the long term. And data will be made available. We're using cellular and satellite telemetry to get the data into the usable hands, and so that we can use it and make decisions both short term and long term. So email me, get a hold of me if you're interested, and we can chat about it. And I look forward to hearing from anybody who's really passionate about this and who can help out.